Thanks for downloading a 3CR podcast. 3CR is an independent community radio station based in Melbourne, Australia. We need your financial support to keep going. Go to www.3cr.org.au for more information and to donate online. Now stay tuned for your 3CR podcast.
Welcome to another episode of Lost in Science. It is science on your radio for another half an hour. You have Chris and Stu in the studio today. Yes, my name is Chris, and today I have a story about stardust and solid smoke.
Stardust and solid smoke.
Yes, stardust.
Not the
and
Neil
solid smoke.
Gaiman book, Stardust.
No, not
The actual stuff that's in between stars. And...
Two meanings thereof. A space probe called Stardust and the actual stardust that drifts between stars, and how it's been caught using solid smoke. You will find out what that is in a few minutes, no doubt. Stu, what have you got to entertain us today?
Well, I was lucky enough, Science Week's over now, but I was lucky enough to catch a visiting scientist from the UK, Dr. Maggie Aderin-Pocock, she's actually taken over from Sir Patrick Moore as the host of The Sky at Night, which is a long-running British astronomy program. But yeah, I caught up with her and talked to her about her research and why she became a scientist, and talked about children's television and how inspiring that can be, and all sorts of things. She did get awarded an MBE for services to education and science. So
we do like that, yes.
Yes.
Okay, well, you will find out about her also in a few minutes, so on with the show. Okay, yes, you are listening to Lost in Science. Now, you may have seen some pictures recently on the internet from the Rosetta spacecraft, which is orbiting Comet 67P Churyumov-Gerasimenko. Pictures of the comet blasting out jets of water. Have you seen those?
Oh, yeah, I have seen. That's the one that the lander actually landed on, that comet.
Yeah, so the Philae lander landed on it, and but the Rosetta
is still orbiting the comet.
Orbiting it, yeah.
Right.
And so something like you see 300 litres of water being ejected every second. The comet is actually losing 26 million kilograms per day during this time that is getting close to the sun as stuff in these water jets blast off.
That's what you call rapid weight loss.
It is. It's losing also 86 million kilograms of dust as well at the same time.
Wow.
Yeah, and you've seen like boulders blow off and this sort of thing. So it's pretty substantial, but I guess it's a fairly big lump of rock and ice, so it can last a while. But it's quite surprising how much is blowing off. Anyway, as you mentioned, Stu, the Philae lander landed on the comet as well. That's kind of a bit of a bouncy landing. Has been sort of intermittent contact back with Earth when it can get a good signal and get sunlight for the power its solar panels. But we've had some analysis from the lander, which of course was sent to analyse what the composition of the comet, or the cometary nucleus as that is known, and it found things like water, obviously, because we're seeing water blasting off, and found carbon monoxide and carbon dioxide. Those are kind of the big ones that are expected. Yep. Also found other organic molecules that are the basic building blocks of things like sugars and proteins and that kind of stuff.
Right. And that this is all just part of the comet, sort of all stuck together.
Yeah, as they found on the comet there. But it's interestingly that this is not the first time that we have examined samples from a comet. And in fact, in 2004, there were samples that were collected and returned to Earth.
Right. So this is like on the spot analysis that's just sending data back.
Yeah, I think there are two instruments, two separate instruments on the lander that are doing analysis. One is, I think, on top of it, one is on the bottom of it. So they're actually getting slightly different things that they're seeing. But yeah, so that is doing analysis in situ. But we have collected stuff and brought it back, which is quite a feat when you think about it. When I say we, the human race.
You mean science in general?
Science has done it.
Yes.
So yeah, it says NASA's Stardust probe, which was launched in 1999, rendezvoused with Comet Wild 2, it's called, in 2004. And it was sent up to catch dust from the comet's tail, or its coma, which is kind of the halo around the comet, using a substance called aerogel. Have you heard of aerogel?
No, but it sounds like something you'd put in your running shoes or...
You could well find it in your running shoes one day. I saw a sample of aerogel recently when I visited the Canberra Deep Space Communication Complex at Tidbinbilla.
Okay.
This is the kind of their deep space tracking station where they have these big dishes that communicate with all these space probes. So, like, for instance, the New Horizons probe, which visited Pluto recently, they were one of the stations that tracked that and communicated that when it was out of view of other kind of NASA
and picked
dishes.
up telemetry and all that stuff.
Yeah, that sort of thing. They've also got a great display of space memorabilia and things about all their probes and stuff. They've got moon landing suits and they've got astronaut meals and this kind of stuff. But one of my favourite...
Isn't that just space food sticks and tang?
It was some pretty disgusting looking brown goo in tubes.
In tubes, yeah.
Yeah. But they had a sample of this aerogel stuff. And it was one of my favourite displays because it really is... It's nicknamed solid smoke, and that's what it looks like. It looks like this little square of stuff it's kind of translucent and looks ethereal, like it's not quite there. It looks like smoke, but it's in a rectangular block.
So you can see through it, sort of.
Yeah, kind of. It's so ethereal. So what it is, it's actually it's made from a gel. So a gel is you'd be familiar with gels from your toothpaste and your other things like that. A gel is kind of a combination of solid and liquid. So there's sort of a solid network,
so like an emulsion, sort of.
Well, it's sort of more like the solid traps liquid inside it. So the liquid is kind of little tiny microscopic droplets that are kind of trapped between a network of the solid, and so it kind of oozes. It doesn't really flow, so it's sort of more towards the gel is technically more towards the solid side of things, but because it's got the liquid in it, it's kind of got that. Well,
somewhere in between.
It's hard to describe without using the term gelatinous and gel-like. Anyway, but yeah, so aerogel is made by supercritical drying of a gel. So basically what they do is they remove all the liquid without damaging the solid part. So you're just left with the solid part and with gas taking the place of the liquid.
Right.
So that's how it gets to be this light kind of almost not there substance. So it's incredibly light, and it can be quite strong. There are photos you can see of it on the interweb where you can see it's like a brick floating on top, well, not floating, but sitting on top of a lump of aerogel, and it's like it's on nothing just about.
But it is supporting the weight of the brick.
It is supporting the weight of the brick.
It doesn't collapse.
It's also a fantastic insulator. So it turns out there's this effect, I think it's called the Knudsen effect, where these little tiny pockets of air that are trapped in it, they're so small that they actually are much better insulators than just free air on its own. So air has a certain thermal conductivity. But when you separate the little pockets of air, it drastically reduces its conductivity. So it's
there's
like
very little heat flow between the little pockets.
It's something like 5 times better insulator than just plain air. And so you can see pictures also of, say, a piece of aerogel which is so light it's balanced on top of a flame of a Bunsen burner, and then on top of that they put things like a flower or some crayons or something that are unharmed by the flame because it's insulated by the heat, but it's also being held up by the heat of the flame. So it's pretty impressive stuff. So it's got a few little applications. Of course, being a good insulator, there's people trying to use it in insulation. It's maybe not going to be the perfect wonder material that everything will be made of in future because nothing is 100% safe. I tried to look up the safety, and apparently you can get kind of a silicate dust from it because it's made of silicate sort of things, which can then lead to lung problems, so lung disease called silicosis. So don't breathe it in, I guess, is the thing, like when it's ground up into dust. But it's pretty impressive stuff. And because it's so light and porous, it was then used. They had a kind of grid of aerogel. So they sent up with this Stardust probe to catch samples of dust. And so when it returned to Earth in 2006, it entered the atmosphere at Mach 36, 12.9 kilometers per second. It was the fastest re-entry ever from a man-made object. Because, of course, it had to be going fast enough to catch a comet. Yeah.
And Mach 36 is 36 times the speed of sound, right?
Yeah.
That's pretty fast.
But it slowed down very quickly and then parachuted to Utah. Then they extracted the dust from the aerogel. Well, they extracted the aerogel and they looked under a microscope to look for the dust that left tracks in it. And they found the same kind of stuff that we're getting now from Philae and Rosetta. So there was, these organic compounds, even things like amino acid glycine was found.
Right.
Which is quite impressive. There's also some silicate rocks like olivine and pyroxene, which is the kind of rocks you'll also find on Earth. So it shows, there's a sort of same kind of chemistry going on there.
Same components go into building comets that go into building planets.
There's also surprisingly some iron and copper sulfide minerals that only form with the presence of liquid water. So it shows that occasionally the comet must get warm enough to melt.
Without losing all of that water as well. Without it
That's
evaporating,
right, yeah. But this wasn't all it found, because they were also hoping that they would catch some interstellar dust, or cosmic dust as it's known. This is the Stardust. So this is stuff that's from outside our solar system. Now, what they did is they used a citizen science project called Stardust at Home to look for this. Basically, they've got specially vetted volunteers to examine the microscopic images. So they had about 1 million tracks of dust through this aerogel, and they had to search through them to find the tracks that were possibly from interstellar dust. And they were usually because they were going faster, and so they were going deeper into the aerogel, because they were moving much faster. The first possible interstellar particle was found by a volunteer called Bruce Hudson. Since then, they've had 6 more identified for a total of 7 possible interstellar dust candidates out of 1 million that they examined. So it was a painstaking job. But it was they haven't found anything consistent out of that. So all these pieces of interstellar dust have completely different chemical compositions, and some of them have unusual crystal structures as well, which kind of indicates that they've formed at different places in space. Different nebulae, different sources in the galaxy, which is not that surprising, I guess, if they're coming from outside the solar system. Yeah. But it gave an indication that conditions in other solar systems or elsewhere are different to what we have in our solar system. So when we examine the comets generally and these things like that, we find stuff very similar to what we have on Earth. Yep. When we examine stuff from outside the solar system, it's very different, which is sounds not unexpected, but it also gives an indication that, there could be quite a diverse galaxy out there.
And, it's kind of exciting. If we found that it was all the same as what we've got here, it would be, everything's the same everywhere you go.
Exactly.
But that's obviously not the case, which is kind of exciting.
It is kind of exciting. So it is interesting news. The first kind of samples, perhaps from outside the solar system, that have been verified. We're gradually getting out there, I guess. In the meantime, of course, the Philae and Rosetta are still orbiting Comet 67P. Philae, I think, is very nearly done. We're not going to hear too much more from that, I think. Well, probably a bit more. Rosetta itself is going to keep orbiting the comet until September 2016, I think, when they intend to crash it into the nucleus. So a spectacular.
They're going to do that on purpose?
Yeah.
Or it's just designed. That's what it's.
They're going to do that. They said the flight controls will steer it in.
Okay.
Just
for fun, or
maybe just to see what it knocks
see what
up.
happens.
See what happens. Anyway, so that'll be the end of that valiant little craft.
Oh well, it's done a good job.
It has.
Our next guest, Maggie Aderin-Pocock, is well known in Britain for hosting the long-running astronomy program The Sky at Night, having presented well-received specials like Do We Really Need the Moon? Which is a good question, for the BBC. She's also a research fellow at University College London in the Department of Science and Technology Studies and an honorary research associate in UCL Department of Physics and Astronomy. And she's currently in Australia as part of the Sydney Science Festival for National Science Week. Maggie, thanks for joining us on Lost in Science.
Lovely to be here. Thank you very much.
Now, I'm going to ask you about the Sky at Night, but first of all, I have to ask, because I ask everyone, because everyone has a different story, but at what point in your life did you realise you wanted to study science?
Well, for me, it happened really young. I'd say sort of age 2 or 3.
Wow. How did you know about science at the age of 2 or 3?
Well, because I used to watch a television program called The Clangers, which was sort of a cartoon program about sort of little animals that lived in space.
Little knitted mice that lived on a moon.
That's it, The Clangers. I loved them. I still do. But also, I found out that it was rocket scientists and space scientists that got people into space. So then and there, I decided I wanted to go visit the Clangers, and so I had to become a scientist.
Well, that's at least you can recognise at that early age that you had a goal to work towards.
And that's been lovely for me, having that dream.
Now, most careers in science are pretty varied, and you completed a doctoral thesis 20 years ago. Can you explain what you actually looked at for that? Because I read briefly what it was about, and I would like to hear from you what you actually studied?
Yes. So for my PhD, I was using sort of an optical technique called interferometry to measure very, very thin films of oil in a high-pressure contact. So when a car engine starts up, the worst thing that can happen is if there's no lubrication on the engine, you get metal-to-metal contact, and then you get sort of fretting, so little bits of metal sort of flake off the engine, and that's not good for the engine in the long run. So what we were doing is we were looking at additives you could add to engine oils so that even when the engine is stationary, you still have a sort of a coating of lubricant over the engine. But the thing is, these coatings of lubricant are sort of down to sort of 10 nanometers, 5 nanometers. So, nanometer, so that's sort of 10 to the minus 9 meters. So a thousandth. So, a billionth of a meter. And so we were using interferometry, sort of this optical technique, to actually measure down to these very, very thin films and actually work out what's happening in these high-pressure contacts.
Right, that makes a lot more sense than the title gives away.
Yes.
Now, I also read that you worked for the Ministry of Defence in the UK after you'd finished your PhD. Without revealing any classified information, can you tell us what you were doing for them?
Yes. For the MOD, this is actually the scientific branch of the MOD.
Okay.
And so I was actually working on two things. The first one was a missile warning system. And this sort of acts, if a pilot is flying along and a missile is launched, the pilot has a certain amount of time to react. And she can sort of send out countermeasures, sort of these pyrotechnic flares, and the heat-seeking missile will automatically go to the flare. The problem is that if they don't realise in time that the missile is coming, of course they're in jeopardy. So what we were developing was a warning system which was looking at UV, infrared, and also visible light, and actually tell someone that a missile was coming, and then automatically set off the flares that would protect them. And to do this job, I actually came out to Woomera, and we were doing some testing in the Woomera Desert, which was fantastic for me.
It's an amazing place to visit, yeah.
Yes. Because it was very dry, and actually all our equipment was fighting the 40-degree heat, pretty hard work, and also the sand was getting into all the cameras. But I sort of made some friends with some guys in the Australian Air Force, and they took me up in their helicopter. So I had a fantastic time.
Got a great view out there as well.
Actually, it was the first time, because I was brought up in London and sort of lived in big cities all my life, and it was the first time I actually saw the curvature of the Earth, and I thought that was amazing. Yeah,
I think in Australia we have a different view of how much a lot of open space can actually mean.
Yeah, it was on a scale that I had never encountered before.
Yeah. Now, after working for the MOD, you moved back to optics and astronomy. Was that always your plan? Were you always sort of attracted back to that field?
Yes. When I was 13, 14, one of the things I did while I was at school is I made my own telescope. So I actually ground and polished my own mirror. And I found that fascinating. So I was always fascinated by optics, and I started sort of specialising it in my first degree. But I was using it for my PhD. And so, but doing the sort of the telescope work was always my goal, or the space telescope work was the ultimate goal. So I went via ground-based telescopy, but it was fantastic. But I went to work out at the Gemini telescope in South America, one of the largest telescopes in the world, and that was mind-boggling. It was truly fantastic.
Yeah, well, I mean, speaking of the Woomera, we get pretty good views of the night sky out there too. So it's we're lucky in that way. We don't have the light pollution that you have to put up with in Europe either.
No, but you're doubly lucky because you've got these fantastic sites that are relatively close by, but also from the aspect of the southern hemisphere, you're looking into the heart of the Milky Way. So all you see so many more stars than we do in the north. So, and that's why many of the very large telescopes are built in locations in the southern hemisphere, because you really do get the glorious view of our galaxy.
Yeah, well, we're lucky in that way.
Yes, I think so.
Now, you've also moved from research into science communication. Now, how did you actually make that transition from being a research scientist to being a science communicator?
Well, actually, because they overlapped for quite a while. And I was having a challenge because I was working as a space scientist on some really amazing projects, sort of projects looking at climate change, sort of Earth observation, also things like the James Webb Space Telescope, the sort of the telescope that's going to take over from the Hubble Space Telescope. And what I couldn't understand is I couldn't recruit anyone. So I was working as a project manager, looking to sort of expand my team. I put adverts in the paper and sort of in the local journals, but I couldn't recruit anyone. And I was thinking, this is bizarre. I'm working as a space scientist. That's a pretty cool title.
Yeah.
And I couldn't understand, why I couldn't get anyone. So I decided it was sort of a PR job, and I had to go out and sell science to people, because I think that's one of the challenges. If you meet a doctor, you have a good understanding of what a medical doctor does. If you meet an accountant, you have a good understanding of what they're likely to do. But if you meet a physicist, they could be working in the city, they could be doing sort of medical research, they could be doing all sorts of things. So I thought I was going to just go out and tell people just some of the things I've done in my career and try and encourage more people to consider careers in physics and in science. So that's how I got involved. I started going out and mainly speaking to school kids, but especially to school girls, because I wanted to show them that being a sort of a woman in science was quite a natural thing to do and incredibly enjoyable.
In late 2013, you took over as the host of The Sky at Night, which is so famous that even I knew about Sir Patrick Moore in Australia as a child. Even though it was never shown here, I actually picked up who he was from a TV show called The Goodies, which was repeated and repeated and repeated as when I was a child. So Patrick Moore to me was a guy in a bunny suit with a telescope. And, commenting on the Goodies flying to the moon because their rabbits had escaped and all these bizarre things. But he used to always appear as himself, so he always had a good sense of humour.
Yes.
But it must seem like big shoes to fill. How does it feel taking over a role from someone who actually still holds the Guinness World Record for the most prolific TV presenter ever? How does it feel filling those shoes?
Daunting, to say the least. I remember in the very first episode I did, it was a little like sort of seeing a rabbit in the headlights. I was sort of slightly stunned. I used to watch The Sky at Night as a child in the UK, and I loved it. And it would tell me about the night sky, and I wouldn't always be able to see the things that they were talking about because I lived in London. But I always would go out and sort of strain my eyes and try and see what was going on. And so I grew up with The Sky at Night, and it was sort of part of me becoming a space scientist was watching The Sky at Night. And so to be offered the job was mind-boggling. And it was, of course, the first thing I said is yes. But then I thought, oh my goodness, those are very big shoes to fill. But it was an amazing honour to be offered it. And I think one of the things that Patrick and I had in common is a real love for the subject. And my goal in life is to try and get that love out there and that passion to as many people as possible.
Well, the original program, I mean, it's been running since 1957.
Yes.
Are you planning to stick around for another 50 years?
Because I think Patrick's record was, I don't think anyone could do it these days, because he was the presenter for the programme for the 57 years, and he only missed one episode, and that was due to chronic gastric flu. And so it's on once a month, so he did it every month for 57 years. And I'd love to have a record like that. I don't know if I'll last that long, but I'd love it if I could.
Now, you are still doing research, I take it. What are you researching at the moment?
Yes. So I don't do as much research as I did before because I was doing scientific research. I was doing science communication, and then I had my daughter, who's 5 years old, and so juggling all three proved to be quite difficult. But now that she's started at school, I'm looking at a number of different projects. There's a lunar project which hopes to send a probe to the moon and then dig below the surface and just see what's down there. So I'm getting sort of involved in that, and also the Square Kilometre Array. I'm looking to sort of be a consultant on one of the projects associated with that. So there's sort of quite a few things going on. I'm still doing a lot of science communication, but yes, I'm trying to get back into the sort of scientific research now that my daughter's a little older.
And hopefully, if you're working on the Square Kilometre Array, you'll get some trips to Australia again.
Yeah, regular trips to Australia would be very, very nice.
Now, one other question I'd like to ask people is, what's the most exciting thing happening in science now, or in the near future?
To me, I've been involved in quite a few. Actually, I've been reporting on quite a few missions, like the mission to Pluto, the New Horizons mission. I was out in Washington while that was happening, and then last year the Rosetta mission. So that was all fantastic. But the thing that really gets me buzzing at the moment is exoplanets. Because to date, we've discovered these sort of planets going around other stars, which to me is fantastic. But now we're doing even more. So not only are we detecting the planets, but we're now analysing the atmospheres of these planets. Now, to me, this sounds like an impossibility. And we can just about make out the star. We can detect the planet going in orbit around the star by looking at the star's wobble. But now we actually want to look at the sort of the very fine atmosphere around a planet, which we can't actually see. But with spectroscopy, which is something that I've done in the past, we can actually compare the starlight without the planet and the starlight with the planet and actually get an indication of what chemicals are in the atmosphere of that planet. And also we're launching a number of space probes which are detecting more and more of these exoplanets. So to me, this is an incredibly exciting time. And as we get better resolution and better sensitivity, we'll be able to detect the atmospheres of more and more of these exoplanets. To me, that is just phenomenal.
Yeah, that's pretty exciting stuff to be able to see what the atmosphere on a planet, light years away is actually made of is pretty amazing.
Yeah, it's pretty mind-boggling, and I love that.
Now, one last final question is, do you still want to go into space?
Very, very, very much so. Although I have tempered my response, because a few years ago, if someone had come and given me a ticket and said, "Okay, Maggie, the space shuttle's waiting for you, off you go," I would have run. But I've got a 5-year-old daughter now, so I'm slightly more tethered to Earth. I would have always taken my husband with me, you see. Because
I was going to say, now you need 2 tickets, or is that the problem?
actually 3, because we all have to go.
We all have to go. Yeah,
that's it. And I have to wait till my daughter's a little older, because I think taking her out into space now is not quite right. But she says at the moment that she wants to be a space artist. So we're both going to go out into space. Now I'm going to do the science and she's going to do the art. So that's the plan for the future.
They do complement each other.
Well, they do, very much so.
I thank you for joining us on Lost in Science, Maggie Aderin-Pocock, and I hope you enjoy the rest of your time in Australia, and thank you for your time.
Oh, it's been my absolute pleasure. And I think Lost in Science is a fantastic title. I think I've been lost in science for many years.
Yeah, so have we. Thanks again.
Thank you.
Okay, that's it for another episode of Lost in Science. It is recorded at the studios of 3CR in Melbourne and airs across Australia on the Community Radio Network with the generous support of the Community Broadcasting Foundation. If you'd like to get in touch with us, you can email us at lostinsci@gmail.com, or you can find us on Facebook, or you can find us on Twitter. And, of course, you can listen to us on the radio same time next week. And once again, Chris, Manisha, Claire and Stu will get
Lost in Science!
Thanks for listening to a 3CR podcast. 3CR is an independent community radio station based in Melbourne, Australia. We need your financial support to keep going. Go to www.3cr.org.au for more information and to donate online.